Rational thought means you're not crazy. That's good. Okay? Because when you start thinking irrationally, well, we have places for people like that, right? And don't get me off on a tangent. Usually a lot of the people in jail do have mental health issues. And of course, how much do we fund that? Do we really care? No. Because if we did, we'd have the money for it and we'd give them help. Okay? We don't give them help. We don't give them a place other than East Hastings. I'm being serious. That's where most of them end up. You ever driven through there? That explains it. Okay, now it's starting to make sense. Yeah, just you really want to. We scared our daughter. I gotta pause this. Stay real. What's the other one? Okay, rational. What's rational? Something that's not irrational. Remember, a number is rational if it terminates, right? That's a rational number. Or it repeats. Okay, if it doesn't do either of those, it's irrational. Can I write this as a fraction? Yeah, that's 3/4, right? Can I write this as a fraction? Yes, I can. If I can write a number as a fraction, that's another definition for a rational number. Okay? That's rational. It is the quotient of two integers. We're doing this, but it's not numbers, it's expressions. Okay? This is a rational expression. It's written as a fraction. Okay? So like I said, we're going to add these things, we're going to subtract them. That's going to be the hard stuff, just like fractions. We're going to multiply them, divide them, okay? But to start, all we're doing is just going to simplify these guys. Okay? So not too bad. All right, it's an algebraic fraction. One variable is the numerator, the denominator. Polynomials, that's the other word for these things. Okay, that's what these guys are. Okay? It's a rational expression, some polynomial over another polynomial. Okay, and blah, 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 I just said that. Okay, the key lies in our ability to factor. I don't know if you remember this from way back at the beginning of September, but I did say, Math 11, if there's one thing we do in this course, it's that. Okay, we don't just do a test on it and move on. We still did it last chapter, right? We still factored some stuff in quadratics, didn't we? Right? You want a quadratic to factor. It's easy to find the zeros if it does. Okay? We did it in other places too. We're still going to do it. So let's quickly review factoring. A greatest common factor. If this is what you have, you remember your little flow chart? Okay? The first thing it said was, if you can remove a greatest common factor, you do it. I don't care if it's a difference of squares or a trinomial or it's got 4 terms that you're going to do it by grouping. If you can take something else out first, you do it. Can I take something out of here and here? Yeah, I can take a 3x out. What do you have left? 2x plus y. Can I do anything else? No, fully factored. Difference of squares, if it's 2 terms, this is what I'm trying to drill my grade 10s on. You got to think that, okay? If it's 2 terms, you're trying to factor it, think difference of squares. Can you take the square root of the first thing? Yeah, it's 5x. Can you take the square root of the second thing? Yep, it's 6y. Plus, minus, you're done. Okay, trinomials by inspection. So, like this guy, some of us do this and then we get to the ones you can't do by inspection and you only want one way to do these, right? It gets all confusing. So then you do these the hard way by splitting this up into 2 terms, and then you can still do it that way. But if A is 1, okay, just like in quadratics, remember? If A was 1, wasn't fatter, wasn't skinnier, then you probably just want to do it by inspection, which means you just throw down a couple sets of brackets and try to piece it together. You only got one choice for x squared. What times what is x squared? X times x. 2. You only have one choice. It's 1 times 2. Then just look at your signs to see that it kind of matches up. Here it's all plus, so with any luck, that should work. Does it work, Lewis? Yeah, just foil it in your head, right? X squared, 2x and 1x, that's 3x. 2 times 1 is 2, and we're done. Okay? You could also do this by inspection, but it might take you a while. That one's actually not bad, because there's only one choice to get 2x squared. It's got to be 2x times x. 3, it's got to be 1 times 3, but let's do it the way we're taught. We want to find two numbers that multiply to not 2 times 1 here. I even skipped that part, didn't I? Because, I mean, there's only one choice. Let's backtrack. What two numbers multiply to 2 and add to 3? There's only one choice. Okay, I didn't even need to do it. Here, there might be a couple choices. What multiplies to negative 3 times 2, and what adds to 5? 3 and 2, 5 and 1. They both might work, right? Okay, so I got to get to a negative. So that's going to give me what? There you go. Multiplying to that one, not this one. 6 and 1. Negative 6, there's got to be a minus here or here. That's plus. So that one's got to be my plus. 6 and minus 1. Does it work? Yeah. 3 and 2, you might want to try that first too, right? But that's it. Okay, so split this one up into 6x minus x. Okay, and then we factor out of the first two. This is now factoring by grouping. If you ever have 4 terms, that's what you do. What do I take out of the first two? 2x. What do I take out of here? Not much. A negative 1. Do I have the same thing in the brackets? You bet. Okay, factor that. What do I got left? 2x minus 1. And with any luck, that'll work. You got to check it, right? Yep. Minus x, 6x, minus 1x is 5x, negative 3. And grouping, well, that's what we just did. If I give you that right off the bat, that's what you want to do. Factor by grouping. Okay, so why are we reviewing that? Because we're going to need to do it. First, let's just investigate something. Here's a rational expression. Here's another one. Okay, if x is 0, what is the value of this thing? So if I substitute 0 in here, okay, I got 2 times 0, which is 0, plus 2 on the top. Okay, I got 0 squared, that's 0, plus 3 times 0, that's 0, plus 2. So this is 2 on the top, 2 on the bottom, and what's 2 divided by 2? 1. Okay, in this guy is a little smaller, so he's a little easier. I got 2 over 0 plus 2, which is also 1. Okay, let's go down to, let's skip this one. Let's go down to 2. If I put 2 in there, I got 2 times 2, 4, plus 2 on the top. I have 2 squared, that's 4, plus 3 times 2, that's 6, plus 2. Okay, so 6 over 10 and 2 is 12. 6/12 or 1/2. What are we going to get here? 2 over 2 plus 2 is 2/4. Is that also a half? What do you think we're going to get if I put 3 in there? I want to save a little time. Do we see a bit of a pattern happening here? Sorry? No, I'm not the value. What do you think? How are these values going to compare? That's all I'm asking. So far, I've gotten the same thing. You think that's, yeah, it's going to happen again. Okay. What can we say about the values of these guys? When x was, well, we just did 0 and 2. Okay? They were the same. Okay? If I put in 4 in both of these equations, yeah, you know what? The answer is probably going to be the same in both of them. Okay? And let's read on. These expressions, that one and that one, are equivalent. It's telling us that. Those are equivalent forms of a rational expression. Write the numerator and the denominator in factored form. Okay? Well, show that this becomes this. Okay. Complete. Can I factor something out of the top? Yeah, I can take a 2 out. Then I have an x plus a 1. The bottom, can I factor that by inspection? Well, it's got to be x times x. And what multiplies to 2? And hey, have we done this before? Plus, plus. That's factored, right? All right. So this is now the same thing, but can I cancel something on the top and the bottom? X plus 1 up there, x plus 1 down here. So that's why these guys are the same. Because when you simplify this down, it's that. It's an equivalent fraction. Okay? Just like 2/4 is 1/2. Here we see it. Here we don't. We got to work it down to see that. Okay? That's why we got the same values when we substituted them in. You stretching?
No, can you cancel? Would that in turn just be x then? Or no?
Let's read on. 2 over x plus 2 cannot be further reduced by canceling terms. The 2 2's cannot be reduced. Okay? Don't do that. You can't do that. That 2 is over top of the x and the 2. Okay? If I want to rewrite that, remember we did a little bit of this in quadratics? I can split it up. Okay? All right? That's the same as this. Do I want to cancel this? What's 2 over 2? Sure. That's 1. Okay? So this is the same as 2 over x plus 1, but you can't do that. So don't. Okay? Okay? All right. We've done this before. When are these guys not defined? Okay, we've done this when we were looking at square roots. Can I take the square root of a negative? No, try it on your calculator. It's going to say not allowed. Okay, error. Okay, can't do. Can I know how many times 0 goes into 1? We don't know. We say undefined. Put it on your calculator. It's going to say error. It doesn't know how many times 0 goes into 1. Okay? We used to call this infinity, right? I already told you this story, didn't I? Okay? Now we call it undefined. We don't know. So we can't do it. That's what they're saying. Right? The value is not defined if the value can't be calculated. The value of x is 0. What do I get? I've already done this, right? That's 0 plus 2. That's 0, 0. What's 2 over 2? Equal to 1. That's okay. What's 2 over 2? That's 1. What if x is negative 1 here? I get 2 times negative 1 plus 2 over, make sure you use brackets, negative 1 squared plus 3 times negative 1 plus 2. What do I have on the top? negative 2 plus 2 is 0. This is 1 minus 3, that's minus 2, plus 2, what's minus 2 plus 2? 0 divided by 0. Is that 0 or is it undefined? I'm not even going to answer that question. Yeah. Okay, but if you try to do that in your calculator, because you know it's smarter than me, we're just going to say you can't do it. Okay? Can't divide by 0. If I put negative 1 in here, because remember these are the same, right? They're equivalent. What do I get? Huh? Aren't they supposed to be the same? Well, when I put in negative 1, I get different values for each equation. Okay? So, for which value of x is this not defined? We didn't do this one, but if you put in negative 2, okay, well just look at this one. That's 2 over 0. I can't do that one either, okay? And that's the only two values that's going to happen. But here is the important one. This one I get a different value for both, okay? For this guy, I only get that value undefined, okay? This one gets something else weird. All right, I'm just trying to get down to this thing, okay? This is what we want to highlight. So remember, I simplified the first guy, this, and I got that. What you're doing, if you do that, is you're removing some of the restrictions. So as long as you, let's flag it, do the restrictions first before you simplify, you'll be fine. If you try to do the restrictions after you simplify, you're not going to get all the restrictions, okay? This one will be gone. As far as this guy's concerned, negative 1's fine, but we would know it's not, okay? Because it doesn't work in this equation. If I put in negative 1, it's undefined, okay? So like I said, this is like an investigation. I'm just trying to show you why, but the biology part says memorize that. Okay, just do restrictions first before you simplify. Okay? Otherwise you won't get all the restrictions. Okay, so just simplify. A couple examples. Express in simplest form, stating the non-permissible values. You notice how this is worded backwards? What do I want to do first? I want to do that first before I simplify. Okay? This thing is not permissible when x has a value of what? You got to think. Okay? I can't divide by 0. That's all you're looking for. What value of x here will make the denominator 0? 0. 2 times 0 is still 0. X cannot be 0. Every other value of x you can think of, that's okay. But if x is 0, you can't do it. Okay? Just like you can't take the square root of a negative, you can't divide by 0. Okay? Because then when we simplify, what happens? That's 12 times x over 2 times x. I'll just split this up like I did in grade 10 in exponents. Okay? What's x divided by x? Yeah, so it's gone. You see how now 0 looks fine? Because I could put a 0 there and it wouldn't be divided by 0, would it? 2 goes into 12 6 times. Okay? So this thing simplifies down to 6x. Is 0 okay for 6x? Sure, that's equal to 0. That's fine. Okay? That's why you have to do this part first. Because you can't divide by 0. Right? Well, yeah, don't get confused with the square roots, right? There's no square root here. There's every other value of x you could possibly think of is fine. We just can't divide by 0. So, trial and error. Can x be -1? Sure. Right? I get -2 in the denominator. That's okay. We just can't divide by 0. Okay? Okay, so number 1, what are the non-permissible values here for number B? If you see what it is, great. And if not, then we solve for it. Okay? A cannot be -1 or -7, because if it is, you see that this becomes 0. What if you don't see that? Because we're going to get to bigger ones you can't see. Then you solve it, just like we did before. This cannot be equal to 0, right? Okay, so -1 to both sides. Okay, A cannot be equal to -1. Yeah. Yes. Restrictions, non-permissible. Yeah, why do they word it differently? I don't have an answer. That's the restriction on this polynomial, okay? Yes, yeah, because the top can be 0. That's okay. 0 is a fine answer. There's nothing wrong with 0. But you can't divide by 0. All right? So once you got that out of the way, it's the hack and slash sale. Okay? It's gone. Right? A plus 1 divided by A plus 1, it's gone. That's equal to 1. Get rid of it. So the simplified answer is A minus 6 over A plus 7. Okay? That's it. What else can we do? If you like brackets, fine, put them in, but you don't need them. That's all you can do. I know you want to hack those A's out. Don't do it.
I know, but why can you do it on the other one and not on that?
What do you mean the other one? There's no pluses or minuses.
So these numbers divide away when
Yes. Yeah, okay, there was brackets here, is that, okay. These were multiplied, right? I'm sorry, I don't have a good way to explain why, just, you can't do it. I can give you substitutions for A and show you, like in 20 minutes, why it won't work, but visually you got to look at that and go, nope, don't cross those A's out. Okay, what are the restrictions here for C? Let me, yeah, well, I need more room. Let me just move this guy over. Okay, let's go green. Okay, do you see what that can't be here in the denominator? I don't. So what do we want to do first? Factor it. Okay, factor the denominator. I want it to be like brackets. Then you see what it can't be. This case it's y, right? Yeah, I could sit here for a while and try to figure it out, trial and error. Well, if y was 3, 3 squared is 9 minus 3. Nope. Okay, y. Just factor it first, okay? What two numbers multiply to -20 and add to -1? So 5 and 4 multiply to 20. I know the difference of those is 1. Now let's piece it together so that it works. I want these to add to -1, so I'll put the minus there. Okay, let's check it. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So this guy, I want to write like this. Okay? A is 1. You want to do this by inspection. Okay? It takes too long to break that guy down. Okay? I know some of you still want to do it that way. I'm not going to say you can't, but, you know, it takes a lot of time. Now, do I want to start canceling here, or do I want to do something first? Yes, restrictions, sure, let's write that. Non-permissible values, same thing, okay? Y can't be what? It can't be 5 or negative 4, because if it is, that's a boo-boo. That's a no-no, not allowed. Can't do it, all right? So once you got that out of the way, y plus 4 divided by itself, anything divided by itself is 1. What? What do I got left on the top? You have to put a 1 there. This isn't just y minus 5, right? It's 1 over y minus 5. That's it. That's all you can do. It's simplified. Fully, completely. Nothing else you can do. All right. This is the last one I got. That one's kind of not bad. You can see what x can't be, but you know what? You're going to have to factor it anyway, because it's hard to see what you can cancel there. Okay? So let's factor it first. Let's go mud brown. Okay, the top, does that look like a trinomial? You think we're going to factor it? Let me just answer this logically. Are we going to give you a question you can't like manipulate and play with and factor? Probably not. Okay? They're all going to factor. They're designed that way, right? We're not going to give you something you can't really do. So, what multiplies to 28 times 1 and what adds to 11? Okay, 7 and 4. So x plus 7, x plus 4. But I recommend you check it before you go on, right? What's this guy called? Meryl? A difference of squares. 2 terms. They got a minus in between them. So that's x plus 7, x minus 7, all factored. Okay. What can't x be? What's my restrictions? Can't be 7 or minus 7. Hey, let's just think quadratics. Let's write plus or minus 7. That's the book's probably going to have its answer like that anyway. Okay. Do I have some equal polynomial on the top and on the bottom? Maya? Nice stash. It's Movember. Is there an equal polynomial on the top and the bottom I can divide by itself? Yeah, right there. Get rid of it. That's 1. Anything divided by itself is 1. What do you have left? X plus 4 over x minus 7. Do I want to cancel those x's, Jade?
No.
Correct. I just asked you something. You didn't respond. So I thought I'd try someone else. Okay? That's it, guys. Don't try to do anything to that. You can't do anything to it. All right? All right. You can watch me do 64 more, or you can actually learn something by doing it yourself.